Hello everyone, today we'll be solving AQA GCSE Chemistry, June 2021. In this particular video, we are going to solve the part 1 from question number 1 to question number 4. This question is about element, compounds and mixture. Substance A contains only one type of atom. Substance A does not conduct electricity. What type of substance is A? So when it says it contains only one type of atom, that means it's a element. And substance A does not conduct electricity, that means it's a non-metal. So it's a non-metallic element. Substance B contains two types of atoms. The atoms are chemically combined together in fixed proportion. So chemically combined in fixed proportion means compound. What type of substance is B? So definitely that's a compound. What is the name of elements of group 0 of the periodic table? So group 0 elements are also called noble gases because they're very unreactive. Okay. Halogens are group 7, alkali metals are group 1. And transition elements are actually block D element. So transition elements, they do not belong to any groups. Which statements about the elements in group 0 is correct? All elements in the group are very reactive. So that's wrong. All elements in group form negative ions. No, they do not take or give electron. The boiling point increases down the group. Yes, the boiling point can increase down the group because even though they're gases, all right, down the group they become bigger and bigger atoms, so they become heavier and heavier. So the heavier the atom, technically it should have a higher boiling point. The relative atomic masses AR decreases down the group. We know that AR always increases down the group. So number third point is correct. Neon is a group 0. What type of particles are in a sample of neon? So because it's a group 0, so it's a noble gas, it is monoatomic and it only contains atoms. So it will be atoms. Figure 1 represents part of the structure of an oxide of a metal. So we can see there are, for each metal X, there are 2 oxygens with each metal X. So the formula, the empirical formula will be XO2. A nanoparticle of a metallic element is a cube. Figure 2 shows a diagram of the nanoparticle. So we can see the nanoparticle has a side of 2.8 nanometer. The surface area of a cube is given by the equation, the length of the side square times 6. Calculate the surface area of the cube in figure 2. Give your answer to 2 significant figures. So it will be 2.8 times 2. Okay, so according to the formula, 2.8 square times 6. This will give us the surface area. Since this is area, so it will be nanometer square. The answer is 47.04 nm square. But since we have to give the answer in 2 significant figure, so we will round it up to 47. Fine and coarse particles of metallic elements are also cubes. The length of fine particle cube is 10 times smaller than length of a coarse particle cube. How does the surface area to volume ratio of fine particles cube compare to that of the coarse particle cube? So you see, fine particle cube is 10 times smaller. Alright, so since it is smaller, that means it has a higher surface area. Alright, so high surface area to volume ratio. Alright, high surface area to volume ratio. So alright, both surface area to volume ratio are the same. No, coarse particles are going to have less surface area compared to the volume ratio. Surface area to volume ratio of the fine particle is 10 times greater. Alright, Well, surface area to volume ratio of fine particle is 10 times greater. Okay, it could be 10 times greater, yeah, definitely. Surface area to volume ratio of the fine particle is 10 times smaller. So it's definitely not smaller, it's going to be greater. This question is about chemical cells and batteries. 3 different types of battery can be used to power a TV remote control. Table 1 gives the information about these batteries. Alright, cost of battery in pounds. Zinc carbon battery 0.17, rechargeable no, and time before needing to replace 5 months. Alkaline battery 0.5 no. Alright, and it's like a longer time, it goes for a longer time, so 12 months. Give one advantage of each type of battery. First of all, zinc carbon battery. We can see that zinc carbon battery is the cheapest. So that's a huge advantage because this is a disposable material. Cheaper the better. So advantage will be zinc carbon is the cheapest. For alkaline battery, we can see that even the alkaline battery is a little bit more expensive, the cost per month is less. So we can say it's long lasting. Nickel metal hydride. Nickel metal hydride is the most expensive, but it is rechargeable. Alright, and then it needs to be replaced more often compared to that of alkaline battery. But the benefit is it is rechargeable. Alright. The other point for this one that can be is do not need to throw away, because just after 8 months you can recharge it and use it back again. Figure 3 shows a symbol printed on batteries. This symbol shows that batteries should not be put into household waste. Suggest why batteries should not be put into household waste. You see, battery contains metals which can be metals such as heavy metals such as nickel, and then alkaline batteries are in alkaline nature, and then zinc. So what happens is that they are toxic. Our general answer will be metal waste can be toxic. Figure 4 shows a chemical cell. We can see figure 4, there is an electrolyte. We can see the metal electrodes that are submerged in the electrolyte. And there is a voltmeter. That means we're trying to make a cell or battery. The order of reactivity of 3 metals are shown, iron being the most reactive and copper being the least reactive. Which combination of metal electrodes would give the highest voltage in the chemical cell? The combination of metal with the most reactive and the least reactive, the difference between them would give the highest voltage. So it will be iron and copper. The voltage produced by the cell in figure 4 depends on the type of electrodes and the type of electrolyte. Suggest one other factor that could affect the voltage produced. So temperature of the electrolyte solution can also affect the rate of reaction, and thereby it can affect the voltage. Another alternative answer could be concentration of the electrolyte. Water is produced in a hydrogen fuel cell. Complete the word equation to show the reaction that produces water in hydrogen fuel cell. So in a hydrogen fuel cell, basically, hydrogen is reacted with oxygen to produce water. This question is about group 1 elements. Complete table 2 to show the electronic structure of potassium atom. Alright, so sodium, we can see the number of electrons and we can see the electronic structures. Potassium, it will be 2, 8, 8 and then 1. Why do group 1 elements have similar chemical properties? So we can see that in group 1 element, they all have the same outer shell electron. So since they have the same outer shell electron, they react in a similar way. They have the same number of electron shells. No. As we can see, sodium compared with potassium has one less electron shell. They have the same number of outer shell electron. Yes, this is the correct answer. What is the type of bonding in sodium? So sodium is a metal, so definitely it will have metallic bonding. Table 3 shows observation made when lithium, potassium and rubidium react with water. So lithium bubbles slowly, floats, moves slowly. Okay. Compared to that, from lithium, sodium is a little bit more reactive. So definitely it will be bubbles quickly. Alright. Definitely potassium floats, and we know that down the group the metal gets denser. Alright. So sodium is definitely going to float. The third point, or an alternative point that can be written, here it is written moves slowly, here it is written moves very quickly, so we can write a point in between. So this is a third point, we can write moves quickly. How does the reactivity of elements change going down group 1? So we can see that going down group 1, the reactivity is actually increasing from sodium to potassium or from potassium to rubidium. Give two ways in which the observation in table 3 shows the change in reactivity going down the group 1. So going down the group 1, we will notice that the bubbles, they start forming more and more quickly. The rate of bubble production increases. We can also state that going down the group, the lithium moves, slowly, and the sodium moves a little bit more quickly. Potassium moves even very quickly. All right, and rubidium explodes into a flame. So we can see that they are moving faster. An extra point will be it goes from no flame to explosion. Which gas is produced when group 1 elements react with water? So when group 1 elements are reacting with water, so that's basically like sodium reacting with water, it will produce hydrogen gas. Sodium displaces the hydrogen of the of the water and produces sodium hydroxide. Sodium fluoride is an ionic compound. Figure 5 shows dot and cross diagram for sodium atom and fluorine atom. Complete figure 5 to show what happens when sodium atom and fluorine atom react to produce sodium fluoride. Complete the electronic structure of sodium ion and the fluoride ion. Give the charges on the sodium ion and the fluoride ion. Okay. So for the sodium, we can see there is 1 electron in the outer shell, and for fluorine, we can see there is a total of 7 electrons in the outer shell. So when sodium gives away this outer shell electron, this outer shell also disappears. So we will have to only draw the previous shell. And since it has lost 1 electron, it will be positive charge. Whereas fluorine already had 7 electrons in the outer shell, but it receives 1 electron from the sodium, so it will be negatively charged. A student investigated the reactivity of metals with hydrochloric acid. So as a method that the student used, measured 50 cm³ hydrochloric acid into a polystyrene cup. Measure the temperature of the hydrochloric acid. Okay, so this gives us initial temperature before starting the experiment. Then add 1 spatula of metal powder into the hydrochloric acid and stir. So approximately, one spatula measure. So this is the start of the reaction. Measure the highest temperature the mixture reaches. Calculate the temperature increase for the reaction. Repeat step 1 to 5 3 more times. Repeat step 1 to 6 with a different metal. Table 4 shows the student's result. Cobalt. Temperature increase given and then average given. Alright. Calculate the mean temperature X for magnesium in table 4. Do not include the anomalous result in your calculation. So let's see. 54, 50, 37, 55. So basically the anomalous result will be the one that is not matching the trend. So we can add 54 with 50 and 55. Then we can divide it by 3. So the average temperature increase is 53 degrees Celsius. Determine the order of reactivity for the metals cobalt, magnesium and zinc. Most reactive. Out of these 3 metals, alright, the most reactive will be the one that has the highest temperature change. So magnesium will be number 1, second will be zinc, and third will be cobalt. The range of measurements either side of the mean shows the uncertainty in the mean temperature increase. Complete the sentence. Use table 4. The mean temperature increases for zinc is 18 plus minus. So when we have to give plus minus, then we have to understand that below 18 the lowest temperature reached is 16 and above 18 the highest temperature reached is 20. So it will be plus minus 2. So when we minus 18 minus 2 we get 16, and when we do 18 plus 2 we get 20. That's how we do it. What type of variable is the volume of hydrochloric acid in this investigation? So volume of hydrochloric acid has to be kept same for all the investigation. So it's a controlled variable. Suggest one way of improving step 3 in the method to give the results which are more repeatable. So step 3, let's see the step 3 first. Add 1 spatula of metal powder to the hydrochloric acid and stir. Yeah, so basically using either the same mass of the metal or using the same number of moles of the metal should be a better process and more repeatable. So same mass. Figure 6 shows a reaction profile for the reaction of magnesium with hydrochloric acid. So B is representing activation energy. Every reactant requires activation energy before it can start reaction. C on the other hand is product, and A is actually the progress of reaction. So guys, for this video we're supposed to finish up until question number 4. We're already done with it. Guys, thank you for watching. Guys, I have made this particular video smaller because most of you watch the video for a very short period of time. So YouTube basically ranks down the video, and so that it is easier for you, so that you can understand it more better and you can focus more better on the segment that you require. I have divided this particular question paper into 3 segments since there are 10 questions. In the first video I'm putting question number 1 to 4, and second video I'm putting question number 5 to 7, 5, 6, 7, and then in the last question paper I'm putting question number 8, 9, 10. So whichever is your requirement, you can actually go through that. I will be posting videos like this in a series, all right, and I'll keep posting almost every day. Currently, the goal is to post 3 videos per day, all right, and definitely I will try to increase it more so that I can cover all the general syllabuses that are actually covered by student. For example, AQA, AP, Cambridge, EdExcel. So guys, yeah, subscribe to the channel, all right, and hang on tight. Let me know what question paper you actually need solving, all right. Write in the comments, and tell your friends, all right. Tell your friends about the channel. Yeah, I'm currently residing in Dubai, all right, in DIP, Dubai Investment Park. So if you are nearby and if you want to basically have tuitions or anything, you can write me in the comments, and definitely I will get in touch with you, or you can write me in the email. All right. So guys, see you in the next video. Thank you for watching, and best of luck for your exam. Bye bye.